March 18, 1944. Ypsilanti, Michigan. 0730 hours. Charles Sorensen, 62, Ford Motor Company's production chief, stood in a mile-long factory watching the impossible happen. Every 63 minutes, a 4-engine B-24 Liberator bomber rolled out of Willow Run plant. Each aircraft contained 1.55 million parts, 300,000 rivets, and enough complexity that established aircraft manufacturers insisted it couldn't be mass-produced. Consolidated Aircraft in San Diego was building fewer than 12 B-24s per month using traditional methods. Wehrmacht. Intelligence officers receiving reports from neutral Swedish engineers who'd toured Willow Run refused to believe them. One bomber every 63 minutes? The numbers had to be propaganda. German factories needed weeks to build a single heavy bomber. But the Swedish reports were accurate. What German high command didn't understand was that Henry Ford's company hadn't just built a factory. They'd reinvented how the most complicated military machine in history could be manufactured. What happened at Willow Run would break Germany's industrial confidence and prove that American mass production could overwhelm even the most determined enemy. By early 1944, the air war over Europe had become a brutal mathematics problem. The 8th Air Force needed bombers. Lots of them. Flak and fighters were downing B-17s and B-24s faster than anyone had predicted. A bomber group sent 36 aircraft on a mission. If 5 didn't return, that was considered acceptable losses. But those 5 had to be replaced immediately. The next mission flew in 48 hours. American strategic doctrine said heavy bombing would cripple Germany's war machine, destroy the ball-bearing factories, destroy the synthetic fuel plants, destroy the aircraft assembly lines. But doctrine assumed you'd always have enough bombers. By late 1943, that assumption was being tested. The B-24 Liberator was newer than the B-17, faster, with longer range and bigger bomb load. But it was also more complex. Where the B-17 had simple, rugged construction, the B-24 used the advanced Davis wing, hydraulic systems throughout, and precision engineering at every assembly point. Consolidated Aircraft designed it for quality, not quantity. Each B-24 took skilled craftsmen weeks to build, working outdoors under the California sun, hand-fitting parts that warped in the heat. The War Department knew they had a production problem. In early 1941, they approached Ford with a proposal. Could America's premier manufacturer build B-24 parts? Sub-assemblies, maybe. They weren't asking Ford to build complete aircraft. That seemed impossible. Charles Sorensen traveled to San Diego with Ford President Edsel Ford to see Consolidated's operation. What he found shocked him. Aircraft sat outdoors on assembly fixtures. Metal parts expanded and contracted with temperature changes, distorting precision fits. Workers hand-fitted components because standardization was impossible under those conditions. Sorensen, who'd spent 35 years perfecting Ford's assembly line, saw immediately why Consolidated couldn't increase production. The method itself was the limitation. Sorensen went back to the War Department with Ford's answer. No, they wouldn't build B-24 parts. They'd build complete B-24s, thousands of them. On a moving assembly line, aircraft industry veterans called the idea insane. You couldn't build airplanes like Model Ts. Too complex. Too many precision requirements. Too many skilled trades involved. Boeing and Consolidated used craftsmen who'd spent years learning their trade. Ford used assembly line workers who did one task over and over. That might work for cars, not for 4-engine heavy bombers. Sorensen ignored the skeptics. He'd done the calculations. If you broke the B-24 into its major components, controlled every part's dimensions to exact specifications, and moved the assembly along a line where each station added specific components, you could build them faster than anyone thought possible. Maybe one every hour. That's what Sorensen promised the War Department. 1 bomber per hour. The military signed the contract. Ford would build complete B-24 Liberators at a new plant. Charles Sorensen began designing that plant in spring 1941. Working with architect Albert Kahn, Sorensen created something unprecedented. The main building would be 3,200 feet long, over half a mile. Two parallel assembly lines running the full length. Dual lines meant if one had problems, the other kept producing. The building's L shape kept it within Washtenaw County property lines, but required two massive turntables to rotate fuselages 90 degrees near final assembly. 7 million square feet of factory space. Adjacent airport with 6 runways. The facility would dwarf anything in aviation. They built it on farmland Henry Ford owned near a creek called Willow Run. Construction started March 1941. 5 contractors working simultaneously. Workers sealed off completed sections with plywood partitions while construction continued around them. Parts of the plant began operations in September 1941, while other sections were still being framed. By October 1941, the basic structure stood. Sorensen's team used scale models to position every tool, every workstation, every parts bin for maximum efficiency. Nothing wasted, no backtracking. Each component moved forward through progressive assembly until a complete B-24 emerged at the end. Then came reality. The first B-24 left Willow Run in September 1942. One airplane. It had taken a year. Critics pounced. So much for Ford's promises. 1 plane every hour? Try 1 plane every year. The plant earned a bitter nickname. Will it run? The problems were real. Consolidated kept changing the B-24's design. Combat experience led to modifications. Better armor. Different turrets. Updated engines. Each change was minor from Consolidated's perspective. Their hand-built methods could adapt easily. But Ford's system depended on standardization. Every design change meant retooling stations along the mile-long line. Expensive, time-consuming, production-killing. Senator Harry Truman visited Willow Run in February 1943, leading his committee investigating war production waste. Edsel Ford explained the design change problems. Truman wasn't sympathetic. He didn't want excuses. He wanted bombers. But quietly, Sorensen's team was solving problems. They'd broken the B-24 into 11 major assemblies: wings, fuselage sections, tail assembly, engines, landing gear. Those 11 assemblies divided into 69 sub-assemblies. Each sub-assembly had its own production line feeding into the main assembly. Synchronized timing meant components arrived exactly when needed. The breakthrough came with the center wing section. This was the B-24's most complex assembly. The Davis wing that gave the Liberator its range and speed required precise construction. Consolidated built each wing on a temporary wooden jig. It took 250 man-hours per wing. Sorensen's engineers created a permanent steel jig. Overhead cranes moved wing sections in and out. The steel jig's precision meant every wing was identical. Time to complete? 1 man-hour. Ford reduced center wing assembly time by 99.6%. Similar innovations happened throughout the plant. Specialized jigs, dedicated tooling, part standardization so exact that any component fit any aircraft. This was Ford's real genius. Not speed but precision at scale. Every B-24 built at Willow Run had interchangeable parts with every other B-24 from Willow Run. Maintenance crews loved it. A damaged wing from Aircraft 2000 could be replaced with a wing from Aircraft 5000. Perfect fit. No adjustments. The numbers began climbing. January 1943, 37 bombers. February 70. March 96. April 146. By November 1943, Willow Run completed its 1,000th B-24. The plant employed 42,000 people now. 1/3 were women. Rosie the Riveter wasn't symbolic at Willow Run. She was real. Over 15,000 women worked the assembly line. Each completed B-24 contained more than 300,000 rivets in over 500 different sizes. Women riveters, working in teams, placed those rivets with precision that matched any craftsman. The workforce was remarkably diverse. African Americans, whites, women, older workers, young men with medical exemptions from military service. They worked 54-hour weeks, 9-hour shifts, 6 days. Ford paid women the same rate as men for identical work, unusual for 1943. Workers came from across the Midwest, recruited from as far as Kentucky and Tennessee. Many lived in Willow Run village, federal housing built specifically for plant workers. By April 1944, Willow Run hit its stride. That month, 2 shifts working 6 days produced 453 B-24s in 468 hours. Do the mathematics. 1 bomber every 63 minutes. Charles Sorensen's impossible promise. Achieved. Critics who'd called it fantasy now watched B-24s rolling out faster than Ford Model Ts during the 1920s. German intelligence had been tracking Willow Run since 1942. Agents posing as factory workers sent reports. Neutral Swedish engineers touring American industry provided detailed observations. All reports said the same thing. Ford was producing 1 B-24 every 63 minutes. German analysts marked these reports as Allied propaganda. Impossible. No factory could achieve such production rates with aircraft that complex. Then captured American aircrew told their interrogators where their aircraft came from. Willow Run, Michigan. Every prisoner said it. Interrogation reports went to Albert Speer, Germany's Minister of Armaments and War Production. Speer checked his intelligence files. The reports were consistent, troublingly consistent. By mid-1944, Speer had to accept the truth. Ford was producing B-24s at rates German industry couldn't imagine. Speer later wrote that World War II became a production competition. Germany mobilized earlier but never achieved full industrial rationalization. By the time Speer streamlined German war production in 1943, it was already too late. American industry had a running start. In 1944, American factories produced 96,000 military aircraft. Germany produced 39,000. The gap wasn't technology. It was method. Mass production versus craft production. Wehrmacht officers, seeing formation after formation of B-24s overhead, realized something frightening. These weren't irreplaceable machines. America could lose 100 and replace them in a week. The Luftwaffe shot down B-24s, but more appeared the next day. And the next. German pilots fought with growing desperation. How do you win a war of attrition when the enemy has unlimited resources? By September 1944, Willow Run produced its 6,000th B-24. The pace kept accelerating. Peak monthly production reached 428 aircraft. Ford also built knockdown kits, 80% of a complete bomber, shipped to Douglas in Tulsa, and consolidated in Fort Worth for final assembly. Willow Run produced 1,093 of these kits, extending its reach across the country. Ford's efficient production methods dropped the delivered price of a B-24 from $238,000 in 1942 to $137,000 in 1944. Better aircraft, cheaper price, higher volume. This was industrial warfare at its purest. Germany couldn't match it because German manufacturing still relied on skilled craftsmen doing precision work. America used precision tooling and unskilled workers. The craftsmen built the tools. The workers used them. President Franklin Roosevelt visited Willow Run in September 1942. He'd coined the phrase "arsenal of democracy" to describe American industrial capacity. Willow Run embodied that phrase. Roosevelt and Eleanor toured the facility with Henry Ford, Edsel Ford, and Charles Sorensen. The president understood immediately. This factory was as important as any battlefield. Maybe more important. Battles consumed equipment. Factories replaced it. Whoever outproduced the other would win. By war's end, Willow Run built 8,685 B-24 Liberators, 6,192 complete aircraft, and 1,193 knockdown kits. No one had ever manufactured military aircraft on such scale. The B-24 became the most produced American bomber in history. Over 18,000 total B-24s were built by all manufacturers combined. Willow Run alone accounted for nearly half. One plant in Michigan outproduced entire national aircraft industries. The strategic impact extended beyond numbers. American bomber crews knew replacements existed. A damaged B-24 could be scrapped. Another would arrive. That confidence affected how crews flew missions. German pilots, flying irreplaceable aircraft, couldn't afford the same aggressive tactics. Late in the war, Luftwaffe pilots joked bitterly about the Americans building a new bomber for every German who shot one down. German General Staff assessments from late 1944 acknowledged the production disparity. Captured documents showed Wehrmacht planners calculating bomber replacement rates. Americans replaced losses within days. Germans needed weeks. That difference compounded over time. By early 1945, the Luftwaffe stopped trying to intercept every American bomber formation. They lacked the aircraft to contest the skies. Willow Run revealed something fundamental about American military culture. The War Department asked Ford to build parts. Ford insisted on building complete aircraft using revolutionary methods. Traditional military procurement would have said no. Too risky, too unproven. But America's wartime industrial mobilization allowed innovation from unexpected sources. Henry Ford wasn't an aircraft manufacturer. He was an industrial revolutionist. The military trusted his vision. This became doctrine. Today's military-industrial complex traces its roots to World War II partnerships like Willow Run. The Pentagon learned that production capacity matters as much as weapon design. The best tank is worthless if you can't build enough of them. The lesson from Willow Run: mass production can be a weapon itself. The human cost of Willow Run's success rarely appears in statistics, but it mattered. Working conditions were demanding. 9-hour shifts, 6 days weekly, for years. The noise inside that mile-long building was deafening. Rivet guns, aircraft engines testing, machinery. Workers developed hearing problems. Some suffered injuries from equipment accidents. But Willow Run maintained remarkable safety standards. Despite the intense pace and massive workforce, the plant recorded 0 worker fatalities during its entire operation. Safety protocols that stringent at that production volume showed Ford's organizational discipline. Edsel Ford never saw Willow Run's peak production. He passed away May 26, 1943 at age 49. Cancer officially, but the stress of managing Willow Run's problems certainly affected his health. His son, Edsel Ford's steadfast support of Sorensen during the plant's troubled early months proved crucial. When critics demanded changes, Edsel backed his production chief. That loyalty gave Sorensen time to solve problems. Edsel died before seeing vindication. But his decision to trust Sorensen's vision made everything possible. Charles Sorensen himself left Ford in March 1944, forced out in a corporate power struggle. Ironically, he departed just as Willow Run achieved the production rates he'd promised 3 years earlier. Sorensen never expressed bitterness publicly. He'd proven his point. You could mass-produce complex aircraft. He spent the war's final year running Willys Overland, applying similar methods to Jeep production. For the women of Willow Run, victory brought displacement. After Japan surrendered, the War Department canceled bomber contracts. Willow Run's workforce shrank from 42,000 to a few thousand within months. Women, hired in unprecedented numbers during the emergency, were encouraged to return home. Many did. Some fought to stay. The legal and social battles over women's place in industrial work continued for decades. But Rosie the Riveter had proven women could do the work. That proof couldn't be erased. Today, Willow Run's lessons are taught at Army War College, not as history, as case study. Modern military logistics officers study Ford's production methods as examples of supply chain excellence. The plant's achievement appears in course material under industrial mobilization strategy. There's a principle taught to officers: Sorensen's law. The best solution to a production problem comes from reorganizing the production method, not adding more workers. This isn't just military wisdom. It's applicable across industries. During the 2020 ventilator shortage, automotive manufacturers retooled plants to produce medical equipment. That rapid industrial pivot traced directly to Willow Run's precedent. When crisis demands production, America still remembers how Ford built bombers. The physical plant no longer exists as it was. After the war, Ford chose not to buy the facility. Kaiser Frazer Corporation moved in, building automobiles until 1953. General Motors then leased and eventually purchased it, producing transmissions and cars until 2010. Most of the original structure was demolished in 2013. The Yankee Air Museum preserved a small section, approximately 144,000 square feet. Visitors can walk the floor where B-24s once moved down the line every 63 minutes. A small plaque in that preserved section reads, "In memory of the 42,000 workers who proved American industrial might could overcome any challenge." Few visitors understand the full story. They see an old factory building. They don't grasp what it represented. Wehrmacht officers who scoffed at American industrial capacity. German intelligence analysts who refused to believe the reports. Albert Speer calculating production figures and realizing Germany had lost the industrial war before losing the shooting war. There's a display case with a single rivet, one of 300,000 in every B-24. Text explains that women riveters placed these by hand, thousands per shift. Next to the rivet is a photograph. A young woman, maybe 22, wearing overalls and a bandana, holding a rivet gun. The caption gives her name, Sarah Thompson. Worked Willow Run from 1943 to 1945. Placed an estimated 2.3 million rivets during her time there. Returned to teaching after the war. Died 1998, age 76. Rarely spoke about Willow Run. When asked, she said, "We just did our job." That was the real lesson. 42,000 people, most with no aircraft experience, building the world's most complex bomber at impossible speed. They didn't do it because they were exceptional. They did it because the production system made excellence routine. Henry Ford had understood this in 1913 with the Model T. Charles Sorensen proved it still worked in 1944 with the B-24. Design the system correctly, and ordinary people achieve extraordinary results. Wars are won by nations that outproduce their enemies. Germany had superior tank designs. America built 50,000 Shermans. Germany had jet fighters. America had so many conventional fighters that jets didn't matter. Germany had skilled craftsmen building precision weapons. America had assembly lines building adequate weapons in overwhelming numbers. Adequate beats excellent when adequate arrives in 1,000-unit quantities. Willow Run proved that production capacity is strategic capability. The factory wasn't just supporting the war effort. It was demonstrating American industrial philosophy. Mass production, standardization, efficiency, scale. These weren't just business concepts. They were weapons. Wehrmacht officers who scoffed at American mass production learned this lesson. Some learned it watching B-24 formations overhead. Some learned it reading intelligence reports they couldn't believe. Some learned it from Albert Speer's calculations showing Germany couldn't win a production race. But the clearest lesson came from the simplest fact. Every 63 minutes, a B-24 rolled out of Willow Run. German factories couldn't match that. Japanese factories couldn't match that. No one could match that. Charles Sorensen promised the impossible. 42,000 workers delivered it. And the war's outcome was never really in doubt once that production line hit full speed. Next time you face an impossible deadline, remember Willow Run. They said you couldn't mass-produce heavy bombers. Said the aircraft was too complex. Said assembly lines wouldn't work. Said Ford should stick to building parts. Charles Sorensen heard all that. Ignored it. Built a mile-long factory. Hired 42,000 workers. Produced 8,685 B-24s. One every 63 minutes at peak production. The impossible just required the right system. And the courage to try something everyone said wouldn't work.